Okay, welcome back to another video, and as you can see, I am using the iPad Pro instead of my computer now because my iPad Pro is actually a lot better. The microphone is already better. In this video, we're going to talk about logarithmic functions and financial models. The first part of this video is going to be mostly about logarithmic functions, so let's get right into that. So first, as we had discussed in the last pre-calculus videos and in videos before, an exponential function is typically like this, right? It's usually like y equals ab times x, right? While logarithmic functions, they go a little more like this. This is a graph of a logarithmic function. This is so this is quite like, this is just kind of review. But now let's go over their context and their data modeling. And here's what I mean by that. So say we have this table of values. We have x, and we have L of x. 2, 3, 5, 7. And a logarithmic function model has the form of two things. It has y equals a plus b lane x, or y equals a plus b log x. And in the context of both, a and b are constants. They both have to be constants. And b is not equal to 0. So just so you remember this. This is quite important to remember. Now, we can use two equations from this table to come up with two equations that we can use to solve for A and for B. So we can formulate, so we can formulate this equation. Lx equals A plus B lane x. The way we can do this, we have two equations. We have L2, let me actually erase this just for more space. This is a lot smoother. It's actually amazing. So say we have L2 is equal to 3, right? Which is equal to A plus B lane 2 because x equals 2, right? And for L of 5, we have L of 5 equals 7, which equals to A plus B lane 5, right? So these are the two equations we can use to solve for these two variables. Now let's do it. Okay, so to find the values, what you have to do, you have to subtract 3 from 7. And the way to do that is by doing this. So what you're going to do here, you're going to take what 7 is equal to, and then also subtract that. And then what you're going to get 4, obviously, because 7 minus 3 equals 4. So you're going to get that. And then you're going to have, because a minus a is just 0, so that cancels out. But then you're going to have b lane 5. Let me erase this for more space. You're going to have b lane 5 minus b lane 2 equals 4. What you can do here you can factor out the b from lane 5 and lane 2. Then what you're going to do here, you can kind of see where this is going. You're just going to divide on both sides. And then you can probably just rewrite your equation from there. So you're going to have b equals 4 lane 5 minus lane 2. When you plug that into your calculator, you're going to get, well, assuming you round it to the nearest, to, let's say, let's keep it simple, 4 decimal places. 4.3654. So let's go ahead and write that down up here. B equals 4.3654. That's what B equals. And then the way to find B sorry, I got confused there. So the way to find B is you have to take this equation, one of these equations. So let's take L of 2, because 3 equals A plus B lane 2, right? We know what B is already. We have the value right here. Now we want to isolate A on both sides. So we just have to subtract B lane 2 on both sides. You can just plug this in. 3 minus 4.3564. No, what am I saying? 4.3654 lane 2. And you will end up with negative 0.0258. And so for your equation, you're going to have Lx equals negative 0.0258 plus 4.3654 lane x. And this would be your equation. So that's kind of the rundown of logarithms for natural log. So let's say we have this equation, and we know that this equals 70. Whoops. And this equals 120. Now we need to find A and B. Well, the first thing you're going to want to do here, like we did in the previous example, you're going to want to do a little bit of complex subtraction here. So what you're going to do, you are going to do A plus B log, hold on, let me rewrite that, just so it doesn't look as messy. A, because remember, A plus B log I is the equation that we're setting up here. And A plus B log 1, log of 1, is equal to 120 as per this equation, right? So we have 120 here. This is essentially 120. And then on the bottom, what we have here is essentially 70, because that's what it's equal to, right? So now we just subtract them. 120, the way I like to do this, subtract this group, and then this group. So A minus A is just 0, so the A's just cancel out. Then for B log, you're going to have B log 1 minus B log this number. And then for 120 minus 70, you're going to have just 50. And then kind of like what we discussed in the last example, you can factor out the b's So what you're going to end up with here is when you factor out the b's, you have log 1 minus log 1 times 10 to the negative 5th power. And then equal that to 50. You're going to divide this whole thing on either side. And you can kind of see where this is going. This is pretty much the same way as solving for a natural log, but this is just like a reiteration because this can be easy to forget. So the more you practice, the better, the easier it gets, essentially. So when you do the math, you get b of 10, b equals 10. You can write that up here. And then you can solve for y using, let's use the 120. So you have 120 equals a plus 10 log 1 and you gotta remember that this is log base 10. Log base 10 of 1 is pretty much just 0. This is essentially 0, and you're multiplying 0 by 10, which also makes it 0. So this is essentially just nothing. And so you get your value, your a value of 120 and your b value of 10. So when you put this equation together, you should end up with 120 plus 10 log of I. This is what your equation will be. Okay, now let's move on to a different topic. So we've talked about y equals ab to the power of x, right? This is an exponential function. It's quite basic at this point, but now we want to go for semi-log plot. Semi-log looks a little like this. This is what a semi-log looks like. Now, the thing about the semi-log is that it's derived from this equation, and I'm going to show you how. So when you have this equation, what you can do here, you can take the log of both sides. So this becomes log of y, and this becomes log of a times b to the power of x. And using the properties of logarithms, you can expand this by saying log of a plus log of b to the power of x. And then you can use logarithmic properties again and rewrite it like this: x log of b. And then eventually, what you're basically going to do here, all you have to do at this point is just remove the log on this side from y. And you pretty much have your semi-log equation. This is pretty much how you set it up. It's quite interesting. I know it's quite interesting because we just magically remove the log from y. But we still have these logs. So it's quite that's like kind of an intriguing phenomenon with this expression. Nevertheless, let's go over an example. Okay, so let's say we have this table and we want to find an equation in semi-log log plot form. So we want to find it in this form, right? So what we're going to have to do, first off, we need to find, it would be easier to find B than A. That's all we have to do right now is just find B and A. That's essentially what we're trying to do. We're just trying to find B and A so we can unravel our whole equation. So to find B, you're gonna want to calculate the average rate of change. And in this case, you would want to do log of f of 2 minus log of f of 1 over 2 minus 1. So what that means, that basically means you can refer back to this table that f of 2 is 90, right? So that's going to be log of 90 minus log of f of 1, which is 40. 2 minus 1. Then when you get your answer, if you round it to the nearest 4 decimal places, you're going to have 0.1761. This is your B value. Oh my god, whoops. I'm not used to this. But yeah, that's our B value. So we already solved for our B value. Now to solve for our A value is actually a much easier process. So to solve for your A value, you essentially just have to do, say, f of 1, or no, not f of 1. Well, yes, f of 1, log of f of 1 minus B. This is how to solve for your A value. So you're going to have log of f of 1, which is log 40, minus 0.761. If you do the math, you will end up getting, if you round it to the nearest 4 decimal places, 1.4259. And so you pretty much have your equation. You have log, or no, you don't have log because this is basically this number and this is basically this number. So basically what you have is your equation 0.1761x plus 1.4259. This is your answer. That is your semi-log plot. Now we want to find our equation in this form. So how do we do that? What we have to do first of all is this. Okay. So all you have to do really, it's actually pretty simple. To convert it to linear model, all you have to do, your A value will be 10 to the power of log base n of A. And for B, it'll be 10 to the power of log base n of B. So in other words, it's going to be 10 to the power of 0.1761 because that's what log base n of B equals. And then for this one, you're going to do 10 to the power of 1.4259. So when you do that, you're going to end up with your A value of 26.6. I don't know where the 1 came from. And then for your B value, you're going to have, what am I writing? You're going to have 1.5. Yeah. And so in exponential form, you would have y equals 26.6 times 1.5 to the power of x. Okay, now let's go over financial models. Okay, so our first financial model we're going to go over is what I like to call, or what is called, the compound interest formula. This is the compound interest formula. And if you took math 3 or the math that's like right before precalculus, you may actually already recognize this formula. I know some of you will. And then there's also an alternative formula, which is for continuous compounding, which is A equals P times E to the power of RT. So PERT, if you will. There's a few scenarios we have. So suppose we invest in, well, actually, let's go over the variables first. So P represents the amount of dollars you're investing in initially. R is the rate that is being compounded. N is how often it's being compounded, like annually, semi-annually, quarterly, monthly, daily, or continuously. And time is just like in how many years will, like in how, like 1 year, 2 years, that's typically what it's measured in. And A is just the amount of measure, is just the amount of money that will be calculated from this formula. Now it's pretty simple. All you have to do here is just plug in the numbers. This shouldn't be too hard. And when you plug in the numbers, you're going to get $5,225. And this represents the amount of money you're going to earn after 1 year with an annual, with an interest rate of 4.5% that's compounded annually. Now, let's say this was compounded like monthly, which is, so N would be equal to 12 because there's 12 months in 1 year. So your N value would change. So you'd have 0.045 divided by 12, the power of 1 times 12. If you do the calculations here, you will end up with a sort of a slightly big number, not too much. $5,229.6991. So what this represents, this is how much money you will earn if it's compounded monthly, because, and it kind of makes sense because it's being compounded more frequently during the year, right? Now suppose it's being compounded like continuously, like at every second. And that's a different thing. That's when we would want to use this equation right here. So what you would want to do because N equals E, 5,000 times E to the power of 0.045 times 1, you would end up with still not noticeably bigger, but not too much. A little over $5,230. And again, it kind of makes sense because you're essentially compounding it at like pretty much every second, at every second. So the more often it's happening, the more money you're probably going to generate. Now let's go over something more complex that still involves this concept. So let's say you're trying to find an annual interest rate. When it's compounded when it's compounded annually, if you want to double an investment, so if A equals 2p in 7 years. Now, first off, you do want to set up your equation here. You can substitute A for 2p because A is equal to 2p, as we can see from what we're given. 2p here. Essentially, what you want to do here, you want to isolate r. We're trying to isolate this variable. Let's go ahead and do that. So what you're going to do, divide p on both sides. This cancels out. So you end up with 2 and what you're gonna do here, you can, if you want, or actually you should, plug in the numbers. So for your n value, you only have 1, and anything divided by 1 is just itself. It's just 1 plus r. And n times t to the power of n times t, which is just 7. So on both sides, that's 7th root. And you can subtract 1. Then you have your formula. R equals the 7th root of 2 minus 1. And when you do the calculations here, you will find that R equals 0.1. So, well, actually, 0.104 to be more exact. What that means, you have an annual rate of 10.4%. That's how you solve for it.